Good afternoon, my YouTube viewers. Crystal here. What I wanted to do this afternoon is I wanted to give you the solution to the Analytics Vidhaya Bankers Hackathon. And basically, the solution that got the highest score on the leaderboard for me, or of all my submissions, was Random Forest with SMOTE. But what I will say is that it wasn't a very high score. It was only 46%, but the highest score was actually only 53%. So I was 7 percentile less than the highest score. I practiced with other models, and I wanted to show you the Keras TensorFlow model where I used one hot encoder, and then I had to, at the end, I had to reverse the one hot encoder, but that only gave me percentile of about 36%, and it wasn't high enough. But if I can ever get a chance to give you a solution that's got a one hot encoder, and then you have to go back and reverse the one hot encoder, then I will. But I didn't get very high marks on this particular Analytics Vidhaya competition. And I'm studying on my own. I have to do it all on my own. I don't have anybody telling me. The only thing I can do is I can watch videos or read things on the internet, and I would prefer to read things on the internet, because if I read it on the internet, then I can copy and paste it, because I'm not really keen on typing all that stuff in myself. If I can copy and paste something, I would rather do that. And since I'm having to learn everything myself, that's all I can do is watch a video or take a free online course or read an article. And then it gets a bit difficult reading the articles, because there's this one publication that you only allowed to read so many free articles a month, and then they want you to start paying. But I do have a way to get around that, because you can sign into your Google Chrome as a guest or sign in incognito. And then I think that's a way to get around these publications that say you only get so many free a month. Because I think that if you sign in as a guest or sign in on another email account, then I think you can carry on reading the free publications. Because I was using my boyfriend's computer, and I had signed in as a guest, and I got to read these publications that normally I don't get to read, because they say, oh, well, you've read all of your free copies this month, and if you want to keep reading, you have to pay, which of course I'm not going to pay, because everybody wants money. And if you go down that route of, paying for this, then somebody's going to want money for something else. So we'll start with the solution to the Analytics Vidhaya Bankers Hackathon. And my solution was Random Forest with SMOTE. So the first thing I did was I imported my libraries. So you can see the libraries that I have imported. The next thing I did was I set up the codes for my scalar. So I set up this code for standard scalar, which I didn't use. Min-max scalar, I think I used that. One hot encoder, I didn't use it here, but I used it on Keras, which I'm not showing you Keras. And label encoder. So I used a lot of label encoder, I believe. And the next thing we did was we loaded our data sets. What I had to do was I had to save the data sets onto my Google Drive. And the reason why is because I couldn't save them onto GitHub, because GitHub has a limit in how big the files can be. And because these files are really big, I couldn't save them onto GitHub. And for that reason, I didn't open a GitHub repository, because I couldn't save the files. So the files are actually on my G drive. The next thing I did was I loaded up my train file, and I would like to say that at some point I'll probably delete those files so they don't take up lots of energy, take up lots of space in my G drive. And then I looked at the train file. You see the train file is pretty big and it's got lots of objects in it. So like what we had to do is we had to take all of these strings and we had to convert them to text files or convert them to integers, really. And we had to put it on a label encoder. In the past, what I had done with the strings, like over here, like less than a year or 10 plus years, is I would strip out the characters and just have a digit. But I decided the best thing to do was put it in a label encoder, which is what I did. And then you notice we also have these null values. These null values have to be dealt with as well. And the reason, one of the problems is because there's so many null values, it's going to affect the outcome. It's going to affect your result. So what I might do here is with annual income, we have a lot of null values. So I might just go through and delete the annual income and see if that increases my score, because what we did with annual income was we just decided to put in the median income, but we don't know what this person's income is, and it may very well have affected the outcome. So what I might do really is just remove annual income from my features and see if that increases my score, which is what we want. We want our score to be increased. So that is something to think about. And we have delinquency. This is another column that's got loads of null values. So we can like take annual income and delinquency and delete those columns or remove those columns from our features. And then when we've removed them from our features, we can see if our percentage has increased, because that's what we want. We want to have our percentage or have our accuracy as high as possible. And I think that's about it. So we're going to have two files that we're going to take out. And the next thing that we did was we looked at the test file. There you go. You have your test file. And then we looked at the sample submission, and this is what Analytics VidHire wants to see. They want to see the loan ID and the interest rate. And then so what we've done is we checked the information of the train file, and we checked the information of the test file. We wanted to see if we had any null characters in the train file. And where we had the null characters, we had length employed, homeowner, annual income, and month since delinquency. But I think that I'm just going to take out annual income, income verified, month since delinquency, or length employed. But what I'll do is I'll think about this, because I think that what I had done was I tried that before, but since homeowner and annual income have got so many null values. Oh, and look at month since delinquency. That's got 88,379. So definitely month since delinquency, we'll take that out. Homeowner, we'll take that out. And annual income, we'll take that out. So those are the three largest columns where you've got the most null characters. And then we looked at the train file, and the train file was the same. You had length employed, homeowner, annual income, and month since delinquency. And you can see that month since delinquency is really large. And then so what I had been doing, so I'll show you what I had been doing. Length employed, I replaced that with mode. So that was just the middle range. And then I had to remove a comma from the numbers. So you can see right here was I removed the comma from the numbers and I made it an integer. So I replaced missing values of homeowner with other. And I filled up missing values with the median, and that was annual income and month since delinquency. But see, the thing is we don't actually know the answer to that, and that may have had an effect on making our accuracy lower. So that's one thing we'll try to take out those 3 columns, see if we can get the accuracy up. The next thing we did was we checked to see if we had any null characters in the train file and the test file, and there were no more null characters. And we did a heat map, so if you want to see how the interest rate compared with all the variables, you can see that. We did a disk plot, so you can see we had an outcome of 1, 2, 3. So 2 was the most frequent outcome, and 3 was after that, and 1 was after that, and you didn't have very many ones. And I made the decision to use SMOTE on that, and it really didn't increase the accuracy that much. If anything, I think it made the accuracy a little bit lower, but I went ahead and left SMOTE in there. And what SMOTE does is that SMOTE puts in synthetic data to try to make it easier for the computer system to train on these values that don't have a lot of information in them. Like you can see here, SMOTE is probably less than 6, and 1 is less than 6, and 2 is over 10. So 1 is like half the size of 2. So that, might affect the training. So if you use SMOTE, what you do is you insert synthetic files or synthetic rows in there to make it easier for the system to train on these values that don't have a lot of occurrence. So we did a violin chart, and what this is this is your loan amount frequency, and that just tells you how much money people were requesting. And you can see the highest figure was about 10,000. And so we had lots of different variations of how much money people wanted to borrow. We had 1,289 or 1,290 variations, in fact. The next thing we did was we checked length employed, and you can see that's a string character. And in the past, what I would have done was I would have taken out all the text and just left it as a digit, but I decided to do something different this time, to use a different tactic. What I did was I put it in a label encoder, and when you put it in a label encoder, then it assigned a numeric value to every category. So what we have now is we have employment history. And you can see the employment history is generally about less than 2. And that's your violin chart. So we did another group by, so you can see now that there were 11 categories for length employed, and you can see how the length employed affects the interest rate, or we will see at some point. The next thing that we had was we checked homeowner. We checked to see if someone was a homeowner. And so we had 5 different categories of whether someone was a homeowner or not. So we put that in a label encoder. And so that's now a digit. Instead of it being a string file, each category was assigned an integer. And so now we have a violin chart of homeowners. So the vast majority of was 0, and then the other one was 4. And you can see how that turned out there. So if you want to see what it was like, 14,148,616 was the highest amount. So that was a mortgage. Most people had a mortgage. And then 12,124,018 was the second highest amount, and that was rent. So that meant most people had a mortgage, and then other people were renting. And some people owned their own home, and other people were others, and other people were none. So the next thing we did was we checked the annual income, and that was really interesting as well. I think it went anywhere from 4,000 to 7.5 million. I believe it's 7.5 million. And so that's a really big disparity of income. So you get these CEOs of companies, and they're going to get that much money. They're going to get a few million a year in addition to all of their bonuses. But I certainly don't get that. I get 5,000. And I'll have to live on that. So what we did was we put the annual encoder, we put the annual income into a label encoder to assign everything a digit, which we may not have needed to do that, but I decided to do it anyway. And so what we did was we did a violin chart so you can see that the highest value. But I may not have needed to do that, probably because it was a number already. Probably I could have just left the numbers there, but I decided to put it in a label encoder. So now we check our annual income again, and you see that it's a label encoded and everything has been assigned a digit. So now what we're going to do is we're going to check to see if the income has been verified. And there's 3 categories where the income was verified, the income source was verified, and it's not verified. And that's a string or an object. So we put that in a label encoder, and we have a violin chart so you can see how everything fits in. But you can see that income verified, income source verified, not verified. It's a pretty even ranking. Like verified was the highest rank, but it wasn't lots and lots higher than the others. So on the violin chart, it pretty much looks the same on the violin chart. And then so we look at how we put the income verified in a chart, and you can see that it's now digits, and you can see it's the same. So 13,138,457, that equates to income verified. 115,388 equates to verified source, and 108,990 equates to not verified. So you can see, especially on these small ones that only have a few categories, you can see it's easy how it's been put in a label encoder. The next thing we have is we have the purpose of the loan, and I had to put that in a label encoder, and then I put it in a violin plot so you can see the purpose of the loan, and you can see all the purpose has now been assigned to an integer. So the purpose of the loan, the highest purpose was 214,739. So we come over here and look for 214,739, and that's debt consolidation. So that means that they're getting a loan to consolidate all of their debts. And the next one after that was number 1, perhaps. One was 72034. So look over here at 72034, and that's credit card. So you're getting a loan to pay off your credit card. So that means you probably shouldn't be putting things on credit. And I was watching a video about somebody else that she pays for everything on her credit cards because then she gets cash back and vouchers and all kinds of things. But I had to give up my credit card for reasons that it's appropriate for me to go into in this video, because this is a professional video and I don't know who's going to be watching it. So I don't want to say why I had to give up my credit card, but I'll tell you personally if you want to know. And then now what we've got is we've got the debt to income ratio, and that's something like debt to equity. Anybody who knows about finance, who studied finance in accounting, is going to know about your debt to equity ratio. And what you do is you compare how much debt you have to how much money you have, and then you assign it a number. So this debt to income ratio had 3953 different variations. So what we did was put in a label encoder, and now we have a violin chart, and you can see that the biggest variation seemed to be between 1,000 and 2,000. So that's like maybe 1,500. So that's your biggest variation of your debt to equity, or what they say is they say debt to income. And I did actually try to just do a chart just to see what the accuracy was going to be, only using the debt to income, because debt to income is a very important ratio, and it gave me a very low accuracy, so I couldn't use it. So we put our debt to income in a label encoder. And the next thing we do is we check on inquiries the last 6 months. And what that is that's how many creditors have contacted the bank about the customer in the last 6 months. And again, that's a value from 0 to 8. So we've got a violin chart that gives you the values. And so the highest value was 0. So we had 173,765 creditors had contacted the bank. That was the highest value. And 1 was the second highest, and 2 was the third highest, and 3 was the fourth highest, so forth. So the month since delinquency, what that was that's how many months since a person had last been delinquent on a loan. And that was 122 variables. So what I did was I put that on a label encoder, and we encoded it. But perhaps we didn't really have to do that, because that was in numeric values anyway, but I just made the decision to put it in a label encoder. And so we've got a violin chart of month since delinquency. And so the highest value was between perhaps like maybe 30 months, something like that. And so here what we do is we got a column on number of open accounts, and you've got lots and lots of variables, lots and lots of categories, 58 to be precise. And so it's a numeric value. I made the decision to put it in a label encoder, but you would not have had to if you didn't want to. The next thing we did was we put a violin chart on the open account, so you can see that number 10 seemed to be the highest open accounts. So here's a group by on the label encoded open accounts so you can see them. The next thing we have is we have total accounts. So there were 99 different categories of total accounts. I made the decision to put it in a label encoder. And then we have a violin chart, and the highest peak was around 20. And then we did a group by of how many open accounts people had. The next thing we did was we checked gender. You can see that men got the loans, well, more than double women did. And we had to put that in a label encoder because it was an object. And so we have a violin chart that tells you in the violin chart that men got loans more than women did. And it shows you that in a chart form. And so we put a group by on the label encoder, and so you can see man is a 1 and woman is a 0. So after we've done all of this pre-processing, you can see the train file, and the train file is all integers except for loan ID, which we're not going to be using anyway. We wanted to do a test to see if any values were null, and there were no null values. So whenever you are manipulating data, it's always a good idea to go back at the end of your data manipulation and see if there are any null values, especially when you're creating bins, because it's easy to make a mistake with bins. So we tested the train file again. Now we set up our features, and so while I'm here with you, I'm going to delete, see if it increases my value, but I can't do it with you because it's going to take a long time. Well, it might not take a long time. We'll see. So that was annual income. And then we're going to have months since delinquency. So we've got months since delinquency, and then we'll see if they're a homeowner. So those are the three columns that we said we were going to delete since they had so many null characters. And we'll try that. And the next thing we have is we defined our X, Y, and X test variables. You see X is train features, Y is train labels, and X test is text features. And then we scale X, Y, and X test using min-max. We use SMOTE to set up synthetic data in order to train your file. We use train test split to split the training file up and with a resampled X and a resampled Y. We checked the values of train X, val X, train Y, and val Y. We use random forest classifier and we fit it. And after we fit it, we made a prediction and we scored it. Of course, our accuracy is going to be different now since we've changed some categories, but we'll just see how that goes later. So we've tuned it. And then when you tune it, it tells you what all of the parameters are. So like if you want to change something, you can change something if you want to. Checked our F1 score. We created a confusion matrix. We created another confusion matrix, and that tells you how many 1, 2, and 3 were predicted, and it's using the synthetic data as well. We checked our accuracy, and now what we did is we put our YPRED in a data frame with the actual value, and we compared it. And so now we've set up YNew, which is predict on X test, and that created something called predictions. And we decided probably don't need to use this X test. I don't know. I'll delete that as well. And then we put in a data frame. So now that I've made these changes, and that gave me, I think, about a 46 or something like that. What I'm doing now is I'm running it. And hopefully it won't take too long to run it. I decided that it's probably a good idea to run. Hopefully it won't take a long time. Well, now it says it's on Google Drive. That's just like the address. Okay, let's see what it's doing. It's done something. I was worried that I might have to do something, but it's working. And I'm going to go down here to the accuracy and see if the accuracy has improved. Okay, so now we're in SMOTE, we're in trying test split, we're checking our columns, and you see that now there's 9 columns each, checking random forest. They're saying it's 55% accuracy. I don't know what the accuracy was before, but now it's saying it's 55% accuracy. I believe before it said it was 57% accuracy, so it might give you a lower prediction. And what you would do after that is you come over here to submission and you check download. But I'm not sure if it's going to take me a long time, and I won't be able to show you this on my screen recorder because my screen recorder only allows one tab. It does not allow me to test on like Analytics VidHaya. So I could I won't be able to test that for you. You won't be able to see it. But what I can do is, so we're on the banking website. So what I can do very quickly, I know you can't see what I'm doing, but very quickly we're going to go, I'm in the banking website now. I'm in Solution Checker, and then I'll just write remove columns. Just write remove columns. And what I'm doing is I'm uploading the submission file, up to loading the file now. I'm adding the solution. And guess what? It only gave me a 42% accuracy. So whenever I deleted those columns, I only got a 42% accuracy as opposed to 46. So that means deleting the columns didn't improve the accuracy. Actually, it decreased the accuracy. So I'm going to have to put the columns back in. But I'm not going to bore you with that because I'm going to have to put the columns back in and then rerun it to get a new accuracy. So what we'll do right here is we come back here where it says features. Okay, so what we took out was annual income. So that's what we took out. That was one thing we took out. And we took out months since delinquency. But what I'm going to do is, since it's so easy to make a typing error, I'm copying and pasting this month since delinquency, because it's just so easy to make an error. And I make a lot of them. I was a secretary for a long time, and I just absolutely, I didn't like doing the typing bit of it. But people don't have secretaries so much anymore. That's one thing that has changed. One thing that's changed, where secretaries they don't have a lot of secretaries anymore, but they do have medical secretaries and legal secretaries. Okay, so now, so what I want to do is I just want to check the accuracy, and we can see the accuracy right here. We just have to wait for it to run. So you see I made a mistake. So you see that's one thing I said I didn't like. But at least you get a chance to see me actually code on the, code in front of you. Because before, usually when I'm on Kaggle, I'm just showing you the code, and when I'm on GitHub, I'm just showing you the code. So this is one of the rare occasions when you've actually seen me do some coding, so you know that I can actually code. I can do it. And I had to teach myself how to do it as well. But let's see what happens. Now it's going through SMOTE, so it's going to take a little while for it to get through SMOTE. But we'll just wait for it to work. So it's gone through SMOTE, and now it's going through random forest. And you can see that our accuracy has improved. Our accuracy is 57%. So since our accuracy has improved, what we'll do is we'll come over here and we'll download it. So you can see that the file is downloading into my download file. And it won't take me very long to check it now because I'm already in the solution checker. So we'll just say add categories, even though you know that you can't see it because I'm only able to do this. And so this is 1536. So you've got this submission file. We're opening the submission file, and I'm adding the solution. And it's, 45.8%. So it's close to 46% because every time we do the test, it gives you a different value. But on my score is 46.197%. So that's good. So you've seen me on my computer go over the solution with you, make a change, and check the solution. And you notice that random forest was the highest value, 46%, and that was 7 points less than the highest score on this hackathon. So that's it. I hope you enjoyed my reading. I hope you enjoyed my solution. So if you like my video, please like, subscribe, and share. If you want to support the work I'm doing, I've got my email address down below for PayPal donations because I don't have enough subscribers, and the only way I can make any money on my videos is to ask for donations. Thank you so much for watching my video and being patient with me while I changed the code and ran the code twice to see if I could improve my score, which I didn't improve my score by what I did, but that's part of what data science is about. Data science is about trial and error. And so we had to see if the score would improve if we took out those 3 columns, and the score didn't improve. In fact, it got worse. So we had to put the 3 columns back in to get back to 46%, because that's what it's all about. It's all about trying to get your accuracy as high as possible. So thank you so much for watching my video to the very end, and I look forward to making another video for you.